This is unit number 4, video number 7, oxidation-reduction reactions. To be able to process oxidation-reduction reactions, we have to understand charge, or what we're going to call charge ultimately is oxidation states, or sometimes oxidation numbers. Because now we're going to assign charge to molecular compounds, non-metal, non-metal. And we have to be able to assign charge so we can track the electrons in the compound. So first thing I want to do is have some feel for charge. Now I've got up here the combustion of methane. Methane reacts with oxygen, produce carbon dioxide and water. We can make a fuel cell out of methane, natural gas, and run a car off of it. So this is a combustion reaction, but it's also an oxidation-reduction reaction. We want to figure out what the effective charge or the oxidation state of the carbon is in methane. So if we write out CH4, you'd say, okay, carbon is one of those atoms we never assigned a charge to. Carbon and silicon's column, we said, well, they can really be anything between +4 and -4, so we're not going to assign a charge to it. Hydrogen we know is +1. We would write this out. We have 1 carbon, unknown charge, plus 4 hydrogens at +1 charge. All of that has to equal 0 because this is a neutral compound. We have x plus 4 equals 0, and x equals -4. This carbon has an oxidation state of -4, okay? So we can write that over top. So, okay, this is -4. The hydrogen here obviously is +1. We get over here to oxygen, O2. Elements in their standard states with no charge listed are 0. They are neutral. So oxygen is going to be a neutral compound. This will be true for all elements. If I write sodium without a charge, it's neutral sodium, same number of protons and electrons. So here we've got oxygen, 0 charge. We get over here to carbon dioxide, CO2, and now we've got an unknown carbon with a known oxygen. Oxygen in a compound is -2, most of the time. So 1x for the carbon, we've got 1 carbon, unknown charge, plus 2 oxygens at thinking ahead here, -2 equals 0. 2 times -2 is -4, so x minus 4, and obviously x equals +4. So the carbon in carbon dioxide is +4. Oxygen obviously is -2. Hydrogen and water, we're going to assign a +1, oxygen -2. So let's look what happened here. The carbon started out in methane, natural gas, as -4, ended up in carbon dioxide as +4. So what happened there? Well, as we went from -4 down here to +4 up here, to do that, we have to lose electrons. Okay? So you can see the loss of 8 electrons. It lost 8 electrons going from -4 to +4. Okay? We call the loss of electrons oxidation. So oxidation is the loss of electrons. Reduction is going to be our gain of electrons. If an oxidation occurs, a reduction must also occur. So if an oxidation occurs, a reduction must occur, equal number of electrons. Law of conservation of matter. We cannot have electrons disappearing on us, and we can't have them being produced. So electrons are being exchanged. So this lost 8 electrons, let's figure out where we gain those 8 electrons. Methane here, the hydrogen is +1. We get over here, the hydrogen is still +1. So hydrogen is not involved in what we call the redox, the oxidation-reduction component. But oxygen here is 0, and we get over here, and the oxygens are -2. Okay? So each oxygen is gaining 2 electrons. How many oxygens are doing that? 4. 4 oxygens started out as 0, and 4 oxygens ended up as -2. So this is the gain of 8 electrons. 8 times 4 is 2.